Let's do an example. Assume Gedanken conditions exist in this example. A stationary observer on Earth sees a very fast car travelling by at 2.5 times 10 to the 8 metres per second. When stationary, the car is 3 metres long. Calculate the length of the car as seen by the stationary observer. Use speed of light. Okay, so here is our stationary observer. Here is watching a very fast car go past. There, the car is travelling at 2.5 times 10 to the 8 metres per second. At rest, it is 3 metres. So its L0 is 3 metres. So if you're in the same frame of reference as the car, you would measure it as 3 metres. That's what it means by at rest. And so we want to know our L value. Okay, so first thing we need to do is work out our Lorentz factor. So our Lorentz factor is equal to 1 over square root of 1 minus v squared on c squared. 1 over square root of 1 minus, now remember we don't need the suffixes if they're all the same. 2.5 squared over 3 squared. You want to pop that into a calculator for me, please? 1.81. 1.81? Sounds about right. Thank you very much. So our Lorentz factor is 1.81. And this is the hard bit, getting that Lorentz factor. Once you've got it, it's easy. So remember our formula, L is equal to L0 over Lorentz factor. So L0 is, what's L0? 3 metres. 3 metres divided by 1.81. What is that? 1.6? Cool. Thank you. 1.66 metres. So the car at rest appears to be at rest is 3 metres long. As it moves faster and faster, closer to light speed, it gets shorter and shorter. So at 2.5 times 10 to the 8 metres per second, our observer outside the car would see the car contracted to 1.66 metres long. Okay? Like I said, that doesn't mean if you're in the car, you won't feel squished to that, you won't feel your length contract. You will see the observer's length contract. Okay? But, yeah, if you're inside the car, you won't feel this, but it is just what an observer would see watching your car going past. Now, another thing I wanted to mention, your things to keep in mind. Okay, if you ever get confused between proper time and proper length and L0 and L and all those things, remember this: the proper time, T0, is the shortest possible time you can measure. The proper length, L0, is the longest possible length you can measure. Okay, that way if you get it backwards, it doesn't actually matter because you'll realise that my proper length is shorter than my actual length. That can't be right. Okay, so just remember that. Okay, your T0 is the shortest it can possibly be, your time. Your L0 is the longest it can possibly be. Okay, so that's how you know if you've got it backwards, if your L is longer than your L0.